Hi, everyone. Are you here all to see the KRO talk? Is that many people interested in KRO? Okay. How many of you have never heard what KRO is before? All right, so you have no idea what you're talking about. Okay, good. All right, hi, everyone. My name is Abdel. This is my first time in your lovely country. I really had some good time in Hyderabad since I came here on the weekend. I'm based out of Sweden, Stockholm. Some of you might know me from the Kubernetes podcast. All right, if you come to me later, I can give you a sticker. My name is, so Abdel is a short for my full Arabic name, which is Abdel Fattah. I'm from Morocco originally, was born and raised there, and I live in Sweden right now. That's my QR code for my link tree. You can check it out later. But let's get to the basics. I think I'm not going to teach you anything new. If you have worked with Kubernetes before, you know Kubernetes has a very basic architecture, right? Control plane, data plane, master slave, whatever you want to call it, where for the most, your control plane is a set of nodes that run the Kubernetes components, the key components, API server, scheduler, controllers, and ATC database. And then your worker nodes are basically where you run your workloads. That's where you deploy your pods, right? And so the control plane of Kubernetes is based on this concept that I think the best way it has been described to me is this thing called a promise machine. What does it mean, a promise machine? Essentially, Kubernetes promises you something will happen eventually in the future. It's an eventually consistent system, which means that when you deploy something to Kubernetes, you're not deploying a how. You don't tell Kubernetes how you want things to be done. You tell it what you want to be done. Typically, we call that an intent. You express your intent in the form of YAML files, right? And then Kubernetes eventually will turn that intent into something concrete. So the very simple example is you deploy a pod. You write a YAML file that calls pod. It has a name. It has a bunch of parameters. You send that to your API server. Your API server will take that, store it in etcd, and then eventually a controller somewhere in the cluster will reconcile or sync up what you expressed, which is your desired state, with what's happening right now in the cluster. So that's why I started by saying it's an eventually consistent system, and it's a promise machine. It promises you things will happen in the future. And the key philosophy of Kubernetes is that it's declarative, so you never express how you want things to be done. You declare your intent. It's extensible. You can actually extend the API server of Kubernetes. You can build your own type of resources. I'm going to talk about it in a bit. And it's universal. It's universal because it uses the same language, which is YAML. This is typically what we refer to as KRM, Kubernetes Resource Model. The whole idea of Kubernetes is that Kubernetes manages resources. Everything that you do in Kubernetes is a resource. A pod is a resource, a deployment is a resource, config map is a resource, et cetera, et cetera. And the whole idea of resources is coming basically from HTTP. REST HTTP handles operations and resources. Your operations for an HTTP server are put, get, delete, post, right? And then your resource is whatever you need to express. So what you do is you declare a resource to the API. But in order for you to declare the resource, the cluster have to know that that resource exists already. So when you deploy a vanilla Kubernetes clusters, the resources that are already available out of the box are pods, services, config map, secrets, blah, blah, blah. But you can also define your own resources. And that's what we call, so this is how it looks like, right? So this is an example of a Kubernetes resource. But you can also create your own resources in the form of an API. And that is typically what we call a CRD, a custom resource definition, right? So if you want Kubernetes to start handling resources that Kubernetes doesn't know how to handle out of the box, deployment, pod, config map, blah, 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 you create what we call a CRD, or a custom resource definition. So a custom resource definition typically looks like this. So this is a custom resource definition that we called it counters, right? The name is a counter. It's a namespace resource, which means it exists in a single namespace. And then it has a schema. And the schema usually defines the fields. So the resource might have a name, a label, annotation, the same way a pod has a port, a container name, blah, 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 right? So the schema is essentially all of these values that are written here in green. So these are the schema part. Then what you put in front of each field is up to the user to define. So once you create this custom resource definition called the counter, right, you can create an instance. You instantiate that. And that's how you would instantiate it. You create an object called myCounter of the kind counter, and then you give it a value. Because in the schema of this CRD, we defined that this object, which is of kind counter, has a single value or a single property, which is type, and which is called value, and the type of this property is an integer, right? And this is how we create our instance. Now, with this in mind, we can basically create any type of custom resource definition, any CRD you want, a database, a pub sub, a car, a masala tea, whatever you want, right? Like you can call it whatever you want because you define the CRD and then you define how that CRD gets instantiated. Now, this example that I showed you is pretty useless if there is no controller, right? You can create as many CRDs as you want in Kubernetes, and you can register them with Kubernetes, and then create instances of that object as many as you want, but nothing will happen unless there is a controller, which is a specific custom piece of code that will listen to that kind of objects and do something with it. This is a very useless counter that we registered. If you create this custom resource definition on the left side, and then you create instances of that object on the right side, all that's going to happen is that they will fill up etcd. They will be stored in the database, but nothing will happen. So that's when controllers come into picture. So controllers are the second part of CRDs. These are custom pieces of code that you can define or you deploy. You can also deploy custom controllers that somebody else have written. And what these controllers do is that they reconcile what the state says, etcd, with the real world, right? So in this particular example, it could be, for example, that what we want to do is we want to create this object in Kubernetes, and then whatever value we put in value, which is 42 in this case, will be displayed on a screen, right? So what you will have to do is you will have to define the CRD, create an instance of the CRD, and then create a controller that once this object is created, will go talk to the screen and say, display value 42, right? Good. And that's essentially the two components of how Kubernetes controller managers work, or all the controllers in Kubernetes work. They work exactly the same way. Every controller is designed to listen to a specific type of object, and once that object gets created, it does something with that information. And the combination of an object created and the controller doing something with it is what we call the control loop. Because all controllers function the same way. They listen, diff, act. So they listen to etcd, or the technical term, the official technical term is they watch etcd. So every controller has a concept where it can register itself with the API server and create a watch on a specific type of object. So it goes to the API server and it goes, I am a controller and I am watching counters. So whenever there is a counter created, tell me, right? And the API server will send updates to the controller each time something happens in the cluster. And that whole concept of control loop is what allows Kubernetes to do the things it does. So for example, let's say you create a deployment that has 3 replicas. A deployment of whatever, an application. There are 3 replicas. They will be running all the time. At some point, one of your nodes go down, right? If the nodes go down, the number of replicas go down to 2. Then a controller somewhere goes like, okay, etcd tells me I should have 3 replicas, but I am watching there is only 2, so I'm going to act on it, and act on it is create a 3rd replica. Good. Now, using this whole concept of controllers and CRDs, we can actually create technically any type of objects, including cloud resources. And that's what basically AWS, Google, and Azure have been doing for a very long time. They all, or every one of them, created their own custom resource definitions. And then they all had their own controller. In the case of Google, it's called KCC, the Kubernetes Config Connector. In the case of Amazon, it's called ACK, the Amazon or AWS Config Connector, I think it's called. And ASO is the Azure something orchestrator. And so, I forgot what S means. So each of these controllers exists today. You can use them. What this allows you to do, and there is, of course, this very open, very common, very famous open source project called Crossplane. Crossplane is KCC, ACK, and ASO together. It's cloud agnostic in the sense that it supports all cloud, but it's not itself tied to a specific cloud. The other controllers, KCC, ACK, and ASO, only work on the specific cloud providers. So essentially what this allows you to do is ditch Terraform. Literally. You have Kubernetes, you use YAML to deploy your apps, but you also use YAML to manage cloud resources. So if you need a database, if you need a bucket, if you need a load balancer, if you need anything, instead of writing Terraform code to provision it, you write YAML file that provision it, right? Good. Now, using this whole concept, we can actually go further, because what we could do is we could create higher level abstractions that allows us to define entire application stacks. So instead of defining a cloud database, a cloud bucket, and a load balancer, I can create a higher level object called app, and that app will generate all of these resources, plus deploy the app and create the cloud resources, right? That's essentially what KRO is. So if you have done any sort of CRDs and operators in Kubernetes, you know that it can be a pain. Writing and managing operators is actually not easy. There are multiple problems that can be caused by CRDs and operators, and one of the most common problems that operators cause is that they DDoS the API server. If you have too many controllers having too many watch orders on the API server, the API server can potentially go down, right? So KRO helps you build this self-service developer platform. So essentially, instead of you having to define every custom resource definition separate and write a controller for it, you can just use KRO to define the custom resource definition. So how does it work? Well, KRO has a very basic syntax. I'm going to show you here a very simple example. Let's say, for example, that you want to deploy an app on Kubernetes, right? Everybody can see the screen, right? Good? OK. Let's say you want to deploy an app in Kubernetes. You will need at least, let me correct myself. Let's say you want to deploy a useful app. You will need at least 3 objects: a deployment, a service, and an ingress, right? Everybody's following so far. So typically, your YAML file will look like this, if it works. So your YAML file will look like this. I have an Nginx deployment, blah, 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 3 replicas, all that stuff, listens on some sort of ports. I have a Kubernetes service that points to that deployment, right? And I have an ingress object. These are, for me, the minimum 3 objects. You might have more. You might have a config map. You might have a secret. You might have a persistent volume claim, blah, blah, blah. So as you can imagine, this could potentially get super long. So typically what you do as a user is you would templatize those. You would create like Helm templates that allows users to import your template and then supply values to change the parameters in your YAML file, right? Very good. Now let's say that you are a SaaS provider and all you do is deploy apps. All your apps look exactly the same. The only thing that changes is the name of the app, maybe the namespace, and maybe the user or the customer that you're deploying for, right? So you could, of course, templatize all of this, put it in a nice, fancy Helm chart, and then just supply one value file per customer or per tenant. Or you could do it the KRO way. So what is the KRO way? So KRO gives us this concept of what we call an RGD, a resource graph definition. So an RGD looks like this. RGDs have 2 sections. There is a spec section and there is a resources section. In the spec section, we are telling KRO what are the fields or the schema that will be exposed to the end user. So in this particular case, my RGD is called simple RGD. It's of kind application, API version 1 v1 alpha 1, v1 alpha 1. And then it has 3 values. It has a name, which is a string. It has an image, so the container image, which is a string. And it has a simple Boolean value that says if ingress is enabled or disabled. These 3 fields, if you want, is what the end user will set, right? So this is the equivalent of the values.yaml in your Helm example. In the resources part of this RGD, we're going to define what gets created when an instance of my simple RGD gets created, right? And so here I say, for every instance of this object, I want to create a deployment, a service, and an ingress. Remember, this is similar to my previous simple ingress example, right? And what I can do is I can take these fields and turn them into a variable. So here, for example, for the deployment, the name of the deployment is going to be schema.spec.name. So every single field that you define in the spec side becomes a variable that you can use in the resources side. And then every resource or every field in the resources side could also be used as a variable in the spec side. So this is an example where I am using the name, this name here, of the resource. I am using it in my app label, both the app labels. I am using it as my, so this is the image, sorry. Schema.spec.image, remember? And then, do you see this section? You remember here we defined my ingress as a Boolean, so true, false value, right? So in the resources section, I can actually have an if condition that says that if my ingress.enabled is set to true, then I will include this. Basically, if this value is set to false, everything after this will be ignored, right? Then, once I define this, this is essentially the CRD, the custom resource definition. Now, how do I create an instance of this CRD? Well, it's as simple as defining this. The kind of my CRD, so the name of the RGD that I created is simple RGD, but the kind is application, right? So that becomes a resource registered in my Kubernetes cluster. So my application will have a name, it will have a container image, a name, basically a false true to my ingress, and then a container image. So this simple 5, 6, 7 lines YAML file will generate all the other objects we saw in the resources section on my RGD. So using this concept, you can actually do a lot of interesting things. So I took an example where I wanted to deploy a WordPress website with a Cloud SQL database. So Cloud SQL is a Google managed version of Postgres, right? But it doesn't matter, it could be anything, right? I wanted to deploy a WordPress with Cloud SQL with a persistent volume claim and an ingress. So this is an example where I am acting as a WordPress hosting company, and each time people sign up to my service, I just spin up a WordPress website for them. So I defined all of this in my, by the way, I'm not gonna try to deploy anything today because I think with this internet, it's not gonna work. So I'm just gonna show you YAML files. I'm just happy that I'm able to get to my terminal. So I defined, no, not that. I defined this here. So this is a resource graph definition that is called WordPress. And it has, okay, well in this case, I just have a simple WordPress Cloud SQL database. And then in my spec section, I basically define this as a kind SQL database. Now, this is not a custom Kubernetes, or this is not a native Kubernetes object. This SQL database is another type of resource that is available to me inside Kubernetes in Google Cloud when I deploy KCC. So because I deployed Kubernetes Config Connector creates CRDs for every single Google Cloud resource. This could be the same for AWS, could be the same for Azure, right? All I am doing is defining higher level abstractions based on existing cloud resources that are available to me in whatever environment I'm working on. So if I was working on AWS, this would be an Aurora database, right? If I'm working on Azure, this would be whatever managed version of Postgres or SQL that I have in Azure. So I can show you another more complex example really quick. I have this, this is the example here. So this is a very, very long example. And I'm not gonna bore you with all the details. All you have to see is in the spec section, I only define a name, a workflow name, doesn't matter what that workflow means, a location, a project ID, and I am getting a status. By the way, remember I told you that every field that you define in the spec section becomes a variable in the resources section. If the resources generate a status, I can report that status back to the spec object. So here, as an example, I created a status field, and in the status field, I am grabbing the bucket URL, so bucket.status.url, and I'm reporting it, which basically means when I create this object called GCS bucket with finalizer trigger, whatever the name is, if I do a kubectl describe, I will have a status portion, and in the status portion, I will have the URL of my bucket. Make sense? So, using this, we can do a lot of interesting things. We can actually define a very high-level example here, web app RGD, so a resource definition or resource graph definition for web application. And inside that, I have a deployment, a service, a Prometheus instance, a service account, a cloud storage bucket, a Cloud SQL instance, IAM policies, and pub/sub topic. So me as a DevOps engineer / platform engineer, I have to define these things once. So I create them only once. I make them available in the cluster. Later, a developer who wants to deploy this entire stack, all they have to do is create an instance of my web app RGD and define their own values in that instance. So your values.yaml file, again, from the Helm example earlier, becomes another object inside Kubernetes, a very short object. Of course, you can make it as long or as short. Now, why this is very useful? It's useful for a lot of reasons. A, I simplify how people deploy applications. But the most important thing, if I'm a security engineer, I might actually not want people to change certain parameters on the cloud resources they define, right? So what I do in my RGD is I only expose to them the fields that I want them to be able to touch. And everything else that I want to keep to a default value, I hide it in the resources section. They, as in the users, the developers, will not be able to edit that. Because I can just use RBAC, role-based access control, and I can not allow them to touch the RGD. So if somebody does kubectl edit on my RGD, once they try to save their changes, Kubernetes will reject it because they don't have the permissions to do that. So this is a very good example for things like, and this example is just Kubernetes cluster, but it could be Kubernetes cluster anywhere, where in our example, and I know that even AWS and Azure, their Kubernetes configuration is quite complex. When you are trying to define a GKE cluster or an AKS cluster or an ACS cluster, you have a lot of fields, like tons of fields. So you don't necessarily want to expose all of these things to the end user, so you just hide it in the resources section, and then you give them in the spec section of the RGD only the things that are allowed to touch. And so combining KRO with something like KCC or ACK or ASO, you can get a single way to define your application specification plus the entire cloud resources stack. So using the high-level definition of KRO, I'm able to deploy my app with a service, with an ingress, or a gateway API, or whatever you want, right? And then under the hood, hide all the underlying details. Okay, I want to set, let's say, a Cloud SQL, a managed Cloud SQL, it doesn't matter where it is, a managed SQL database, a managed Postgres. I can actually even go further. If I am doing like some sort of multi-cloud strategy, I can have the same KRO objects available in every cloud provider, right? And then based on where people are trying to deploy their applications, I can route them to the cloud provider available in that region. So I might have, AWS in one region, Google in one region, Azure in one region, and I can just give people a very simple platform that says, deploy my web application, blah, 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 location Asia, and then I just take that and then go deploy it on a region in Asia with whatever cloud resources or whatever cloud provider I have available in that particular region, right? And so there is a lot of other examples. Just to be super clear, KRO is not doing anything new. KRO is just using the existing CRD concept inside Kubernetes. Crossplane have been doing this for a very long time, and this whole concept of higher level abstractions, they call it in Crossplane compositions. For those of you who worked with Crossplane before. The key difference is KRO is a Kubernetes native object. Today it's not because the project is still in alpha and there is still controllers you have to deploy, so it's not available out of the box in Kubernetes, but the aim is eventually to make this available out of the box. And KRO is a collaboration between Google, AWS, and Microsoft. So it's an open source, 100% open source project, and the 3 companies are contributing on it. So, a couple of things to keep in mind. It's experimental, so you use it at your own risk. Don't tell them that Abdel told us to use it. Or if you do, tell them my name is Michael. KRO plus KCC, or KRO plus ASO, or KRO plus ACK could be potentially the single way you might want to deploy or to manage cloud resources on any cloud provider. And I'm gonna not cover the last one. I'm just gonna stop here. Thank you very much. Thanks for coming to my talk. And if you have any questions. I think we have 5 minutes, right? And thank you so much for the connection. Thank you. Do we have any questions? Yes. Is there a microphone? Yes. There is a question there first, and then, yes. They have a microphone somewhere. Yeah, it's the person standing over there. Okay.
Thank you.
Sure.
So what is the roadmap towards KRO development? Like, what is the immediate priority, and what you guys are looking for in terms of contribution?
The immediate priority for now is to get it to version 1, because it's still in version 1, 0.4.
Yes.
So get like a first version stable. That's the main kind of focus of the team right now. And then eventually, one of the things I personally want to work on is just document more examples, show like how can you create like more complex deployments. But I only happen to know Google Cloud. So it would be good if somebody can contribute like AWS examples and GCP and Azure examples.
So it's more of like you have CRDs, which is already available, and over which you add an abstraction.
Correct. Okay. So KRO is just an abstraction layer on top of that.
Got it. Thank you.
No worries.
Yeah.
Yeah.
So using KRO, we can combine a lot of objects, right? For example, deployment pod, you have shown a lot of objects. So when it comes to deletion, right? Let's say if I wanted to delete something, does it maintain the order? For an example, if I'm using, external secret operator, I want to have a cluster secret store and, some kind of resource. Does it maintain the dependency?
Yes. It has a reconciliation loop. So the example I showed earlier where I define a deployment, a service, and an ingress, if I would go and kill the deployment, it will be recreated because it's a controller.
It basically does reconcile, and it does understand the order as well, dependency order.
Correct. Correct. Yes.
Cool. Thanks.
No worries. Any other questions? Yes.
How would you support multiple clouds with the same definition?
How would you support multiple clouds in the same definition?
Yeah, I mean, let's say you want to deploy cloud resources under the same umbrella, right? So for
As long as the Kubernetes cluster has all the underlying CRDs, you can do it.
Yeah, but then your main YAML would have to be a superset of all the cloud resources for GCP and AWS and whatnot, right?
So I don't know why you want to do that, but it's possible. To answer your question, it is possible.
Is that a use case you want to support?
I don't think so. I think that the main challenge you're going to face with that particular example is not the fact that you can define everything in YAML file. The main problem is going to be how does the controller authenticate, right? Because KCC, ACK, and ASO, they're controllers. Yeah. And in order for one of these controllers to talk to the API of the cloud provider, they have to authenticate themselves, right? So basically, this means that if you have one cluster anywhere that has all the CRDs of all the cloud providers, right? And you try to define one YAML file that creates a Cloud SQL database in Google Cloud, a bucket in S3, and something else somewhere else, that single controller will have to authenticate to Google, AWS, and Azure. So the challenge is how are you going to get that authentication to work? That's the main problem.
Okay.
Make sense?
Yeah, okay.
Okay. There was another question over there. There's a question there. Sorry? It's just a controller and CRD that you deploy. So the question is, how does it work for standalone Kubernetes clusters? It works on any Kubernetes cluster. It's just a CRD and the controller. So it's pretty straightforward.
Hi, Abdel.
Yeah.
So we are using Terraform right now to procure all the...
Can you speak slightly?
Yeah, we are using Terraform right now to procure all the infrastructure. We tried out cross-plane. We wanted to do some kind of a POC because this was like really active, going on for a long time. So what we observed is whenever we were upgrading maybe the database, which was created by crossplane, like from Postgres 15 to Postgres 16, it was trying to delete that component instead of upgrading it. So would we be facing the same challenge over here if we use KRO?
So I didn't work very closely with crossplane, so I cannot answer the question about crossplane. Okay. But I understand your question. I think the problem you have there is not the fact that these tools doesn't support upgrades, is however the cloud provider upgrade works. Yep. So if you are using a product that doesn't support upgrading without deleting the resource and creating it, then KRO will just follow that.
We were using AWS Aurora. So
yeah, I don't know how AWS upgrades for databases work. So
yeah, it does it without any deletion or something. So
yeah, I understand. It is a challenge. I think KRO will just delete the objects and create it again. It's not gonna know how to upgrade it because the challenge again is not the fact that KRO wouldn't support it. The challenge is however that resource gets upgraded.
Got it.
So that intricate internal working of how the cloud provider supports their product is something that would be very hard to bring it into KRO. Make sense?
Yeah, makes sense. Thank you.
Hi.
Hi.
No, okay, one of you.
For you, so you mentioned that CRO is still on production. If I had to do something similar right now, do you believe that this is a combination of creating my own Helm chart and using something like Pulumi to make this infrastructure deployable?
I didn't get the question. Can you repeat?
So, do you believe that this is kind of like a replacement for making my own Helm chart with custom resource definition and operators, plus doing something like Pulumi or Terraform to do the deployment?
Correct. It is potentially a replacement for using multiple tools to do the same thing. It could be a replacement for Helm, although you could templatize CRO with Helm, right? So you don't have to drop in a replacement for Helm. You could use Helm to define CRO resources. But it is potentially also a replacement for like Terraform or Pulumi. Because basically, the question you have to ask yourself is whether do you like managing things using Pulumi or Terraform, or do you prefer just to do Kubernetes? So the key difference is one, Kubernetes gives you a single interface, so everything is YAML. The other tools, you will have to maintain two systems. You will have your Helm, which is YAML-based, and you will have your Terraform or Pulumi, which is like a configuration language.
Yeah. Where does it maintain the state? Like Pulumi has its own backend, for example, to maintain like cloud resources?
The state is in etcd. It maintains state in etcd.
So for non-Kubernetes resources as well?
For everything, correct, yes. Okay. Yes. Okay.
Yeah, so just adding to that one only, that was my question as well. So if I have an SQL database I have created using Terraform, and I'm trying to create the same one, then I'll get I'll just get a message that it already exists, right?
Correct.
But in this case, if I create a database using CRO and then try to create it again, then in all probability, it is like going to contact the API of the cloud provider, and then the API is going to fail.
Correct.
So
if you try to create the same resource twice, it will fail.
Yeah, but is that like...
okay, so
is
that's...
it better to fail before?
That's an implementation detail of the underlying controller. In our particular case, again, I only know Google Cloud, so there's only one I can cover. In particular case, in Google Cloud, KCC, so Kubernetes Config Connector, allows you to import an existing object, right? So you might have a Cloud SQL database which you created manually or using ClickOps, right? You can go into KCC and tell KCC, label the database, the resource, and then KCC will know it exists and will not touch it. I don't know how the other ones work. Make sense?
Hey, hi.
There was somebody waiting for a long time, yes.
Yeah. Thank you for the talk, first of all. Yeah, so basically, we also have the same scenario, and we are using Kubevilla as a thing. That also does the same thing. Are you aware of Kubevilla and how your solution is different from Kubevilla?
Not that much, not intimately, no.
Not so. That is also promising the same thing, and we are also using that in-house, and it has multiple versions also released. So
okay.
I thought, yeah.
Are you happy with Kubevilla?
Yeah.
Just continue using Kubevilla. You don't have to worry too much about CRO.
Okay, thank you.
All right, I think I have to empty the room, right? Because somebody is coming. Yes, last question, and then we can talk later. Yes.
So we have a similar flow where we are having a Kubernetes operator, and then we have Helm charts, which essentially packages Kubernetes native resources, and then we use the operator to control them. One of the advantages that we get using that is that we could do a lot of peripheral things, like adding ownerships if we have to, adding finalizers, like looking at the delete timestamps and all those kind of stuff. Will those be available with CRO as well?
Finalizers, yes, because they are a Kubernetes native resource. Labels, you can just label objects, right? Is that what you need? Like, you just need to label objects for ownership.
So is there like a specific ownership? Will that be added to all the resources that are created by the CRO?
So CRO doesn't tag resources. It's the underlying controller that will do that. So if you're using KCC on Google Cloud, KCC will label the object. Does that make sense? Okay. But if you need to label objects, you can just, in the resources side, add the labels, basically.
So define our own labels and ownerships if you want to.
Correct, yes. All right, I have to leave the room because somebody is coming 5 minutes after me, but I'll be around, and then you can just come to us.